Good evening, dear students. Welcome back to Chemistry Kingdom channel. So today onwards we are going to discuss the 100% fixed question from second PU and first PU chemistry and mathematics subject. So I am going to start chemistry capsule. So in today's class we are going to talk about the first capsule of chemistry, that is 3-mark question from haloalkanes and haloarenes, 100% guaranteed. Yes, without wasting time, let us begin the session. Within 500 seconds you will get 3 marks. So stay tuned guys, without wasting time we'll start the first class. Yes, first capsule. Explain SN1 mechanism with an example. Explain SN1 mechanism with an example. Yes, they may ask like this also. Write the mechanism involved in the conversion of tertiary butyl bromide into tertiary butyl alcohol. Like this way also they can ask the question. The mode of asking question may be different, but answer is same. Yes, it involves two-step mechanism. Yes guys, before going to the mechanism, first of all you have to write the reaction. First I will write the reaction. What you have to take? Tertiary butyl bromide. Tertiary butyl bromide, like this. This is tertiary butyl bromide, and treat with any base like a KOH or aqueous KOH or NaOH. Like this base you have to treat with. Then what you are expecting? Yes, this Br, this K eliminate as a KBr and OH is going to attach here. This is tertiary butyl bromide gives tertiary butyl alcohol. Yes, it will give tertiary butyl alcohol like this. So how it going to takes place, that we are going to discuss in the today's class. Yes, so mechanism involves 2 steps. As you know, mechanism involves 2 steps. Step 1, we'll discuss step 1. See, in first step what we are going to do. So carefully observe. First of all, you take the tertiary butyl bromide, then you go for the reaction. What you are expecting? Carefully observe. Tertiary butyl bromide I will take. Now, between carbon and bromine, which is more electronegative guys? Between carbon and bromine, bromine is more electronegative. More electronegative means it will pull the electron towards itself. So clearly, bromine will take the electron from the carbon, right? So clearly, these electrons are transferred to bromine like this. And remember, in organic chemistry, one who takes electron gets negative charge. One who donates electron gets a positive charge. Yes. So what you are expecting? What you are expecting? Bromine will take electron and went back as a Br minus, and carbon is giving electron. Carbon will get a plus charge. Yes, carbon will get a plus charge, and remaining as it is. 3 CH3 groups are there. You write 3 CH3 group as it is like this. Carbon with positive charge is called carbocation. Is called carbocation. I hope you understood. So here electrons are taken by bromine, hence minus charge. Electrons are given by carbon, hence plus charge. Now tell me, tertiary butyl bromide is stable or carbocation is stable? Tertiary butyl bromide is stable. So we are preparing stable compound to unstable compound. So is this process is fast? No, this process is slow, because stable to unstable, and there is a chance to come back also. Therefore, we have to show double-headed arrow like this, and the reaction is very slow. So in the first step, what is happening? Carbocation is formed or not? Hence, the step name is formation of carbocation. What is the first step? Formation of carbocation. Carbon with positive charge is called carbocation. Now second step, this nucleophile is going to attack on carbocation. Yes. So what is the second step? Step number 2. Carefully observe here. Step number 2. See, in step number 2, what you are going to take? You take this carbocation again. What is the carbocation here? We got CH3, single bond CH3, 3 times of CH3 out, right? Okay, with positive charge on carbon. Now what you are adding? This KOH is there, no? Out of KOH, K will react with Br minus, eliminate as a KBr. What is remaining? OH minus is remaining. No, that OH minus is going to attack on carbocation. So what you are expecting? Carefully observe. This OH minus is going to attack on carbocation. So clearly OH will bond with a carbon. So what you are going to get? You are going to get like this, CH3, CH3, this is as it is. Now what is there? OH is going to attach to carbon like this. Now this is carbocation. This is tertiary butyl alcohol. Which is more stable? This one. How do you know, sir, this is stable? Because this is not having any charge. So clearly this is a stable compound. Now unstable to stable compound. So clearly this reaction is fast and only forward reaction will take place. You have to say only single headed arrow, and this reaction is fast. I hope you understood. Now there is a chance of attacking backward also. Carefully see, carbocation is there. OH can attack front side also, back side also. Hence, SN1 is proceed through racemic mixture. Front side attack, retention. Back side attack, inversion. Both are taking place simultaneously. Hence, SN1 reaction proceed through racemic mixture. Very good. So, in this step, what is happening? This is called a nucleophile. Nucleophile is going to attack on carbocation to form the product. So what you can explain now? Nucleophile, yes, nucleophile will attack on carbocation. Nucleophile will attack on carbocation to form the product. I hope you understood. So if you write this much, definitely you will get 3 marks. Properly how to write. I hope you understood. Yes. Now first reaction 1 mark, first step 1 mark, second step 1 marks. So next question, that is SN2 mechanism, we will discuss. Before going to that, just you take a screenshot, then we will move to the next part. You have taken screenshot? Yes guys. So this is the second question of today's session, that is explain SN2 mechanism with an example. Remember, SN1 mechanism involves formation of carbocation. So clearly tertiary alkyl halide is greater than secondary alkyl halide is greater than primary alkyl halide for reactivity. Now here SN2, it is not involve carbocation, therefore reverse reactivity. We will discuss after this. So carefully see, second question. Now out of SN1 or SN2, definitely they will ask one question for annual examination for 3 marks. Yes. Explain SN2 mechanism with an example. Explain SN2 mechanism with an example. So here I have taken methyl chloride. What I have taken? CH3Cl means what? Methyl chloride, which is converted into methanol. So carefully observe, KCl is eliminated. What is eliminated? KCl is eliminated. So it involves only one step mechanism. First of all, it involves only one step mechanism. In one step only everything is going to happen. So first step, carefully observe. Take methyl chloride. What you have to take? Methyl chloride. So I will explain like this. Methyl chloride, I will write in this fashion so that you can easily identify what is happening. CH3Cl I written like this. Methyl chloride. Now what is there? This OH minus is there. No, it will attack backside. It will attack backside. Why, sir? Because OH is minus. Cl is also electronegative element. There is a lone pairs here. Correct or not? So this negative repel each other. Therefore, front side it will not attack. It will attack back side like this. I hope you are getting. So as due to attack at the back side, what you are expecting? You are going to get transition state. What you are going to get? Transition state. Carefully observe here. That transition state is written in a square bracket. This OH and carbon bond is forming. Carbon and Cl bond is breaking. Carefully see. Middle carbon you write as it is. 3 hydrogens are there. I will add 3 hydrogens in this fashion. 3 hydrogens as it is. This carbon and chlorine bond is breaking. So I will show with a dot line. And OH and carbon bond is forming. Again I will show with a dot line. So this is called, what this is called? A transition state. What this is? Transition state. Means it is not stable. Immediately it will give product formation. One step only everything is happening. Getting? So clearly this Cl is eliminated. OH is going to form the bond with it. So what is the final answer we are expecting? OH, CHHH. Carefully observe, Cl we have taken at the right side, OH we got at the left side. Hence, it is called inversion of configuration. What it is called? Inversion of configuration. So what you can explain? In the same step everything is happening. Nucleophile will attack on backside to give transition state, which on going to give the further product in one step only. Right? Yes. So you have to explain like that only. Nucleophile will attack backside to give product by passing through transition state. Yes, in this fashion you have to write. Nucleophile is going to attack on backside backside of methyl halide to form product through transition state formation and you are observing in one step only everything is happening. And rate depends upon, since it is attacking backside, rate depends upon primary, because this H are smaller group, they should be smaller group. If they are larger, it is very difficult to attack, correct or not? So primary greater than secondary greater than tertiary alkyl halide is the order of reactivity of SN2 mechanism. I hope you got the concepts here. The next question, last question in this session, that is difference between SN1 and SN2. Nowadays they are asking difference also, right? So we'll discuss that question also. Please take the screenshot, then we'll move to the next question. Yes, guys, this is a third question. Difference between SN1 and SN2. Nowadays they are asking this question also in the annual examination. If you see the 3 model question paper issued from the PU board 2024 for this academic year, this question was asked, right? So without wasting time, we'll discuss SN1 mechanism and SN2 mechanism. First pointer, in both case, remember the SN1 name itself indicating it is a first order reaction and unimolecular reaction. This is a second order reaction and bimolecular reaction. Yes, first point, first order unimolecular reaction. First order unimolecular reaction. First order unimolecular reaction. This is first order, second order, sorry. This is second order bimolecular reaction. Second order bimolecular reaction. Sir, what is this first order and second order, sir? Means our in SN1 case, rate is directly proportional to concentration of Rx. Rx means alkyl halide. But here rate is directly proportional to, yes, rate is directly proportional to both Rx and nucleophile. Hence here one, total order is second order. I hope you understood. Yes. SN1 mechanism involves or favored by polar solvents. Favored by polar solvents. So which solvent is required here? Polar solvents. And here it is favored by non-polar solvents. Favored by non-polar solvents. Non-polar solvents. Polar means like water, they contain hydrogen. Non-polar means like a CCl4, CS2, they do not contain hydrogen. Yes, next one. Here order of reactivity. Reactivity order. Reactivity order. What is reactivity order in this case? Reactivity order is tertiary Rx is greater than, secondary Rx is greater than, primary Rx is greater than CH3X. What is Rx, sir? Haloalkane or alkyl halide. Tertiary alkyl halide is greater than, secondary is greater than primary. Because as already you studied in SN1 mechanism, carbocation formation is there. So tertiary carbocation is more stable than, secondary is more stable than primary. Now come to this case, order of reactivity here, reactivity order is reverse. Reactivity order, because here backside attack is there, no? So here reactivity order is what? Primary Rx greater than, secondary Rx is greater than, tertiary Rx, like this. First of all, methyl will come. This is regarding order of reactivity. Last case. So order of reactivity is over. First order unimolecular reaction, second order unimolecular reaction. Rate directly proportional to Rx. Rate directly proportional to Rx as well as nucleophile. Favored by polar solvent, favored by non-polar solvent. Reactivity order, tertiary greater than, tertiary is highest. Reactivity order, primary is highest. And it involves racemic mixture formation. I told you during mechanism only. It involves racemic mixture. Racemic mixture formation. In that case, it involves Inversion. It involves inversion of configuration. It involves inversion. Inversion of configuration. Inversion of configuration. Which one? This one. What is a racemic mixture? Both D and L isomer. In the next video, I will explain. That is regarding what are enantiomers are there. You will come to know. Means here both side, back side and front side, both side attack takes place. Here only back side attack takes place. I hope you followed regarding the today's video. If you are getting any doubts, means you can comment below. Please share the video among your friends so that every student can get a benefit of it. In the next video, again I will come up with a new capsule and 100% guaranteed question. Thanks for watching. Thank you.